Hello everybody, welcome to Universe Sandbox. And today's video, we're going to be looking at a custom solar system I made. This is the Unaluchu system. So the first planet in the system is Tartanis, which is orbiting the star Unaluchu, which is 1.3 times the mass, radius, and luminosity of our Sun. This planet Tartanis is basically 1.8 times the mass of Earth and 90% the radius. It is tidally locked due to its rotational period and orbital period being the exact same. So as you can see, the sun-facing side of this planet is nearly molten. And the night side is like 112, 113 degrees. Which isn't very good to live on anyway. So Tartanis has basically 2 G's of gravity, meaning that you weigh 2 times heavier on that planet. But here is Sulfus, which, from the name, you can tell is covered in sulfur across its surface, like Jupiter's moon Io. That's why its surface is so colorful. Its atmosphere is also mainly made of sulfur. And due to volcanic eruptions on Sulfus, sulfur gets pushed into orbit and eventually gets picked up by Sulfus's moon, Cineban. Sorry about that. So, Cineban is 2 times the mass of the moon and way closer to Sulfus than our moon. It has like a lot of sulfur, like highlands from like sulfur from Sulfus landing there. And yeah, it orbits every 2.25 days. The next set of planets is Branis and Desertos. These planets are basically binary planets, which means they orbit a common center of mass in between the two of them. They are both around 20% the mass of Earth and 60% the size. Desertos is a desert planet that has small amounts of like liquid water lakes at the very like north and south poles, as you can see. And they do like vary in depth season from season. Like sometimes there's actually like water oases in the middle of the desert at the equator. But right now not really. So, Desertos is just barely cold enough to sustain liquid water. Branis has no atmosphere and has a reddish tint. Its most prominent feature is its huge mountain range near the equator. This mountain range was formed during a large impact event in the past. The next planet is Odysia. Odysia has 3 moons, 2 smaller ones, and 1 moon-sized moon. Odysia is a habitable planet with civilization on it. It has white sandy beaches bordering its green continent. Going further out from Odysia, you have Upempendus, which orbits super close to Odysia, giving it an egg-like shape. It is very visible from the surface of Odysia. The next moon of Odysia is Ak. It's very mountainous. This is likely because of a long past impact that also turned the moon on its side. As you can see, the magnetic poles are like basically like sideways. So basically, like a ancient moon, Odysia, or an asteroid hit it on its side, making it rotate like this. Then the final and most distant moon of Odysia is Morb. Morb is around 1.3 times the size of our moon, and 1.3 times the mass. It has slightly lower gravity than the moon, but basically the same. Morb's surface is considered to be very young due to its lack of craters. Scientists theorize that either Morb has some form of process that erases its like surface over time, like plate tectonics. The evidence for this is like large mountain ridges going across the surface, which could be where like the different tectonic plates go down into the mantle. This is because like this moon Morb is massive enough to actually have a form of plate tectonics, having some small volcanoes across its surface. It's tidally locked to Odysia and takes 16 days to orbit. The next celestial body is Discus. As you can see, it spins extremely fast, and because of that, it has like a extremely oblate shape, meaning its equator is way wider than its poles. It takes only 2 hours to rotate once, meaning that if you were living on this planet, you could only get 1 hour of sleep. It's slightly further out than Odysia. This means like the temperature on the surface is slightly colder, but like due to its fast spin and like extremely toxic atmosphere, there's no life documented on the surface of this planet, despite the liquid water. But there is the possibility for life to be living under the oceans of Discus at the equator. Well, I say oceans, but it's more like just a single ocean, due to the massive spin of the planet drawing all of the water to the equator. Discus is 75% the mass of Earth and 96% the size, meaning it has around 82% the gravity of Earth. The next celestial body is Cern. This is a dwarf planet that's extremely small, only being around 1/10 the mass of the moon. It only has like 1/10 the gravity of Earth, so you'd feel 10 times lighter on this dwarf planet. It has an icy crust, which covers most of the surface, and spins pretty fast. It takes around 4 years to orbit the star. The next object out from the star is Massie. Massie is a huge gas giant, around 2 times the mass of Jupiter, and 26% larger. It has a rotational period of 0.4 days, giving it a slightly oblate shape, but nowhere near as much as Discus. Its first moon is Sunter, which orbits extremely close to the gas giant, almost at the Roche limit. The scientists from Odysia think that one day, Sunni will get pulled so close to Massie that it will get ripped apart and turned into a huge ring system around the planet. Sunni is very, much like Jupiter's moon Io, but even more volcanically active, and way larger. It's around 14% the mass of Earth, making it 11.4 times the mass of the moon, and nearly 2 times the size. It has half the gravity of Earth, and takes just 11 planets to orbit hours to orbit Massie. The second moon of Massie is Carbonton. From the name, you can tell that this moon is mostly made of carbon dioxide. It's 75% carbon dioxide. Scientists have no idea how this much carbon got onto this moon. That's still to be researched. It's tightly locked to Massie, and it is around 1.3 times the mass of the moon. Its surface is covered in a thick layer of carbon dioxide ice. The next moon of Massie is Titanus. This moon is around 10% the mass of Earth, or 8 times the mass of the moon. It's half the radius of the Earth, or nearly twice the size of the moon. This moon has a thick, nitrogen and methane atmosphere. And on the surface of the planet, you may notice lakes. But these lakes aren't made of water. They're instead made of methane. So you could call this moon kind of like a super Titan type world. It has much bigger lakes than Titan, and it's much larger in mass and radius. The next moon of Massie is Cryos, which is mostly made of water ice, meaning that it's possible that this moon has a subsurface ocean underneath its crust. It's around 2 times the mass of the moon, and around 1.6 times the size. Cryos takes 9 days to orbit Massie. Massie takes 13 years to orbit the star. The next planet out is Burman, which takes 33 years to orbit the star. It's extremely oblate due to its extremely short rotational period of 8 hours, and it's 87% the mass of Jupiter. Burman's first moon is Cern, which has a mix of an icy and rocky crust. It's so close to Burman that it's being stretched out into an egg-like shape, giving it large cryovolcanoes and fissures on its surface, like this one here, or here. It's pretty small, only being 2% the mass of the moon, and takes 9 hours to orbit Massie. Burman. This also means that Burman takes a shorter time to rotate around its axis than Cern, even though it's extremely close to orbit. The next moon of Burman is Titanus. This moon is made of 75% water and is around 2% the mass of the moon also. It takes almost a day to orbit Burman, and it has some cryovolcanoes too on its surface. It may contain a subsurface ocean also. The next moon of Burman is Ion. It has an icy slash like rocky shell. One side of the planet is like mostly like rocky, and the other side is covered in like this yellow chemical, likely from a large impact in the past. Like maybe like a outer moon smashed into it, covering one side in like this dust, if possible. The next moon of Burman is Athena, or Athena. It is around 2 times the mass of the moon and a third the radius of the Earth, or 20% larger than the moon. It takes 5 days to orbit Burman and has a thick carbon dioxide atmosphere, meaning despite its large distance from the sun, its surface temperature is only minus 9 degrees, opposed to like the minus 114 degrees Celsius of Cryonis. Or, if you were to put this into Fahrenheit, it would actually be above 0. When Celsius is still negative, meaning that there's no liquid water on its surface for now. But later on in the system's life, it will get hot enough for liquid water to exist, possibly becoming habitable. The next moon is Tartanis. As you can see, it has like a large impact scar on one side, which was caused by a large object slamming into it, like side on. This spun up the moon super fast, making it slightly oblate around its equator. It still has a small like internal heat from this large impact, indicating that it happened relatively recently in terms of like cosmic scale, possibly happening in the last few million years. It takes 14 days to orbit Burman, but it's not tidally locked due to that collision, meaning it only needs 1/10 of a day to rotate. It's around 40% the mass of the moon. And like, it's super like fast spinning. The next planet is Titanus. This ice giant is around 34 times the mass of the Earth, making it a super Neptune class planet. It's 3 times the radius of Earth and has nearly 3 years of gravity. Its first moon is Icarus. It has an extremely red surface, likely due to the tidal forces from this planet, its home planet, making its surface heat up. It's a small asteroid moon, only being 26 kilometers across, and it takes 4 hours to orbit Titanus, meaning that it orbits Titanus faster than it takes for Titanus to rotate. Titanus' second moon is Glaceon, made of mostly water ice and a bit of silicon and iron. It has a thick crust of water ice, giving it like a cyan blue color. Actually, more like a pale blue. It's about 1.4 times the mass of the moon, and it takes 16 hours to orbit Titanus. The next moon of Titanus is Ceranian. It has an extremely dark surface, having a small crust of carbon dioxide, which makes up about 4% of the moon's mass. It took a long time for scientists to discover this moon due to its extremely low albedo, which means it reflects an extremely low amount of light. The next moon and final moon of Titanus is Task Crust. It's another asteroid moon, being about 20 kilometers across. It is suspected to be a captured asteroid due to its inclined orbit, and takes nearly 19 days to orbit Titanus. The next planet is Molife, being a mini Neptune. It's about 12 times the mass of Earth, making it slightly less massive than like Uranus and Neptune, which are like a bit larger in mass. But it has a slightly larger radius than Uranus, due to it being less dense. It has actually lower gravity than Earth, due to its extremely low density. It takes about 123 years, to orbit its star. Its first moon is Imac, which is a small icy moon, around 1% the mass of the moon. It takes 21 hours to orbit its star. The next moon of Molife, or is it Molife, is Burman. It has a bluish, like, rusty color, with a lot of the surface being like a silver blue, and the other half being like a rusty red. The next moon of Molife is Sulfus. It's about 5% the mass of the moon. It takes 7.5 days to orbit. It has like a large ridge going across part of its equator. It has an extremely mounty surface. The next moon of Molife is Marana. It has a colorful surface and orbits retrograde relative to the rest of the moons. It has a big purple spot on its surface, suspected to be made of amethyst gemstones. It has a strange canyon near its north pole, filled with blue gemstones. Estimates say that this moon could be worth as much as $100 quadrillion, minus the 1,000 quadrillion dollars that would take to bring it back to Odysia. So it makes complete economic sense to harvest. Am I right, asteroid mining enthusiast? So, as we see, it takes 15 days to orbit Molife retrograde, meaning that it's likely a captured moon. The next dwarf planet from the star is Romeo and Juliet. These two dwarf planets orbit each other, kind of like Pluto and Charon in our solar system. But, they technically are binary, due to the center mass, a tiny bit out of Romeo. But sometimes it dips in, meaning that the system isn't full binary. you can still consider Juliet a moon. So Romeo is covered in a thick layer of ice, with which obscures its deep ocean of liquid oxygen under its surface, which has a black color. It has about 2 times the mass of the moon, making it like a super Pluto. It takes 131 years to orbit the star, and Juliet is like a reddish brownish color, being around 30% the mass of the moon, and takes 2 days to orbit Romeo. So as you can see, as they orbit the star, there's like a little wobble motion that Romeo does. So moving even further out, you have Molife's comet. This comet spins extremely fastly and comes inward towards the inner solar system every 117 years, making its orbital period slightly less than like Molife and Romeo. It comes actually within the orbit of Sulfus for a short time, making it the second closest celestial body to the star. The next planet is Mimisus, which has an extremely elliptical orbit, with its periapsis still being outside the orbit of Romeo and Molife. It's suspected that Mimisus got this way from interactions with the nearby brown dwarf orbiting the star. It's extremely dark, even at its periapsis, which it is at right now, being extremely dark and cold. It's also technically the third most massive planet in the system, being nearly half the mass of Jupiter. Its moon, Molife, is around 3 times the mass of the moon, and takes about 1.2 days to orbit. It has like an icy crust, but underneath it's made of mostly silicate and iron. Moving even further out from Mimisus is Sunni, which is a brown dwarf star that's an extremely distant orbit around the main star in Luchu. It is currently unknown whether Sunni formed with Luchu as a binary partner, or it was eventually captured during a close past when Sunni was still like an actual independent star. Sunni has 3 planets. Though some scientists think that Sunni may have had 4 in the past, due to there being like a field of debris just in front of Sunni in its orbit. These field of debris come out to being almost 2 times the mass of the Earth, and seem to be originating from the Sunni system. In this debris disk, there are several large, like moon-sized objects, which originate from this former planet that used to be the closest to Sunni. It's suspected by like interactions with other planets in this system, this formal planet got into the Roche limit of Sunni, which is nearly 40 times the mass of Jupiter. This caused it to be ripped apart and for like the debris to be scattered across interstellar space. The first planet around Sunni is Borak. Borak is 70% the mass of Earth and 1.16 times the size or radius. It takes 2 days to orbit Sunni, and it has a mountainous rocky surface. The second planet is extremely unusual, called Elimon. It has the same radius of Earth while only being like 19% the mass. Due to this, scientists have like classified it as a micro Jupiter or a gas dwarf, meaning it has the same composition as a gas giant, but is the size of a terrestrial planet. It only has 0.13 Gs, meaning that you would feel 10 times lighter on Elimon than on Earth. The last planet in the Unalutru system is Mora, being a small ice giant, roughly 6 times the mass of Earth, making it a mini Neptune. It takes 2 months to orbit the star and rotates every 6 days. So that's it, the Unalutru system. I made this completely from scratch. And I hope you enjoyed this video. And anyways, goodbye. I have to end this video quick before my voice dies. Sorry everyone. Goodbye.